So guys, we still discuss 2.7b composition of functions, and this is part 2. Okay, so yesterday we do some examples, and then we solve practice problems, and I just give you the corrective assignment today. But before giving you a mastery check, we're gonna discuss the part 2. Jackie, you can sit beside with Isaac, okay? Okay, so we're gonna continue now finding composed functions. So please have your workbook on topic 2.7b. So it says right here, let f of x is equal to x squared minus 1, and g of x is square root of x, and find the function h of x is equal to f of g of x, meaning whatever is the result of the f function to compose with the g function, the result is the h function. Okay, but when we look at this, the f function is outside and the g function is inside. Therefore, from the given right here, we're gonna copy this, but since this is x squared, you're gonna put that in parentheses, make some space such as this. So we have h of x is equal to f of g of x, implies that the f function outside, which is x squared minus 1, so you put this square minus 1. Okay, is the first step here, guys. And what is the inside right here? What is the inside function? The g of x. And what is g of x defined? Square root of x. So I'll just do color coding that this is to be written inside, since the g of x is inside. Is that clear, guys? So what you notice right here, noticing that h of x is equal to, and then noticing right here, you guys speak up,
X minus 1.
x minus 1. Why?
Because it cancels out.
So with this, square root of x and square cancels out, right? So therefore, our final answer is x minus 1. So h of x therefore is x minus 1. So thank you, Isaac. Any question? Pregunta. So what is defined right here? What is the outside function? F is outside, so we copy the f, which is 2x minus x squared. But make sure instead of writing x for this one, you put that inside the, or in parentheses. And what is to be written inside the parentheses is the g, which is x plus 1, because g of x right here is inside function. Clear? So we're gonna simplify this in h of x as h of x is equal to f of g of x implies that this is, so what is f? F is defined as 2x minus x squared. So we write this way. Instead of writing x, put that first in parentheses. Okay? So, and then minus x and then square. Clear, guys? And what is to be written inside? Since g of x is inside, so the function g of x should be inside the parentheses. Clear? So what is to be written inside? The x plus 1. So we have x plus 1 and then x plus 1. Okay, before we simplify, any question, clarification on this? So we say now h of x. So what we do with this, we distribute, right? So 2 times the inside x plus 1, so 2 times x is 2x, and then plus 2, very good, so plus 2, then minus. Okay, now you should be careful putting this in parentheses. Thank you. So what we do with this, we FOIL, but I gave you a technique last time, right? So this would be x squared, product of the inside, x times 1. What is x times 1? Just x, right? Then double the 1. So that becomes plus 2x. And then the square of 1 is 1. And then we still have to simplify this. We're gonna distribute the negative. Careful, because this is the common mistake of the students, distributing this. So we say h of x is equal to 2x plus 2, and then minus x squared minus 2x, and then minus 1. Alright guys? So what you notice right here, what cancels out? We cancel out the 2x, right? And then we combine like terms, as 2 and negative 1. What is 2 minus 1? It's gonna be 1. Okay, so continuing this, so h of x is equal to, and then we cancel out the 2x, positive and negative. So what is left is, what is 2 minus 1? 1, okay? So 1, then minus x squared. So 1 minus x squared. Any question? Or you say yes?
Aren't you supposed to put the x squared before the 1?
Yes, you can have it. And thank you. So Jackie said, we put x first. Yes. So in the order, so this will be finally h of x is equal to negative x squared plus 1 as the final answer. Okay? Can I move this up now? You guys done? Can I move this up? Okay. So we say domain of a composed function. To find the domain of a composed function, what do you think? What is your idea about domain?
Input x.
Okay, the input x, right? Or the values of x. That's the domain, the x value. So, to find the domain of a composed function f of g of x, we have 2 restrictions. How many restrictions do we have? 2. So, to consider, so this is the first restriction. First, since we are using g of x as an input, we can only use x values that are in the domain of g. X values in the domain of g. Second, the output of g of x must be in the domain of f of x. To check this, we look at a new function f of g of x. Any restrictions on the domain of f of g of x must also be included. So use problem 1 to find the domain. Can you still remember what problem 1 is all about? Anyway, we go to problem number, this should be number 2, okay? Just check this or correct this. That should be 2. So, let f of x is equal to square root of x minus 1, and g of x is equal to x squared minus 8. Now, find f compose g, then state the domain. How to rewrite this one? How to rewrite it? Are we rewriting? Yes or no? Yes, right? If it is written this way, then you can rewrite as f of g of x. So what is the outside function? The outside function is f and the inside function is g. So we copy down the f function, but if the f function has an x, put that as parentheses. Okay? So f function, we have square root of, and then this has an x, right? This has an x, so what did I say? Parentheses. Very good. Put that in parentheses and then minus 1. This is the definition of f of x. Then what is to be written inside? The g of x is the inside, which is x squared minus 8. Here guys? So x squared minus 8. Okay, and then what we do? Can we rewrite this as square root of x squared minus 9? We are combining negative 8 and negative 1, which is negative 9. And then what does the first restriction says? Can you please read it? The first restriction. What's the first restriction, Miha? Can you read it loud?
Number
for
one?
me? Number 1.
First, since we're using g of x as an input, we only use x values that are in the domain of g.
Okay, so that means we focus on the inside, not the entire thing, which is square root. So just ignore the square root, but focus on the inside of the square root. What is the inside of the square root? X squared minus 9, right? So to do the domain, you're gonna have greater than or equal to 0. You're gonna equate into greater than or equal to 0. Okay, that's how you do to look for the domain. Okay, so next we're gonna simplify. This gives us x squared is greater than or equal to, we are adding both sides by 9, right? Adding both sides by 9. Do I have to show you? No need. So we can do mental math, right? So change this negative to positive. Okay, therefore what we have now, this means our values of x would be, we're gonna take the square, or we're gonna square both sides, right? Square both sides. So we're gonna have greater than or equal to plus and minus 3, which implies that one of the values of x is greater than positive 3 and the other value of x is less than or equal to negative 3. Okay, now this is not yet the final answer because we're gonna have to do that in Remember in Algebra 2? I was telling your teacher in Algebra 2 to be strict in using parentheses and what? Bracket. Now this is less than negative 3. What are the numbers less than negative 3? Negative 2 is less, right? Are you sure? Sure?
No.
I'm just telling you. What do you think are the numbers less than negative 3? Less. Say it.
4 to negative infinity.
Negative 4 to negative infinity. You're right. And what are the numbers we have less than or equal?
Negative 3.
Negative 3 all the way to the right, right? To the right. Okay. So, right here, we're going to have to say, you said a while ago infinity. So, this means open interval, right? Open interval. So, to negative infinity, and then since this is greater than or less than or equal to 3, this means this is closed interval. Okay? Closed interval. And what else? It's gonna have a union of what? Since this is greater than 3, that means it's gonna be closed interval. So close right here at positive 3 and then all the way to
Positive infinity.
very good, positive infinity. Now, question, is it parenthesis or bracket? Parenthesis, because this is an open interval. Okay? Clear, guys? So this will be your final answer. Do it right here. And I need you to box your final answer next. That's why yesterday, Mr. Cooper came here and said, Mr., are you still doing the strict implementation of notation? And I said, yes. The parenthesis and the bracket is very important. Why? When you take AP Calculus, it is understood that you know everything, right? You know everything. Okay. Question 4A. If you have questions, just let me know. Okay, moving on to problem B. Find g function of f of x. That means the g function is outside, right? And how about the f function? Inside. So we're gonna copy the function g. So we say g of f of x is equal to, this is the g function, right? So what did I say a while ago? If it has an x,
Parentheses.
parenthesis. Very good. Thank you, Jackie, for reminding the class. Okay? Always. Always. So, we have the g as x squared minus 8. This is the g function, right? This is the g function. Can you just put this as what? Imaginary x right here. Imaginary x. Okay? So, what will be written inside the parentheses? The f. What is f? What is f of x? Square root of x minus 1. Very good. So, square root of x minus 1. Okay. What you notice now? Anything cancels out? The square and the square root, the radical, right? So this cancels out. This one. So what is left now? So it must be x minus 9. Am I right, guys?
Yes.
X minus 9. And then, what we do now? What we do now? is there a restriction inside? Is there a restriction inside? This is the inside right here. Since we all know that f of x is equal to square root of x minus 1 by definition, and it has a restriction. Okay, what is the restriction? Can you not see? What is this restriction? What we do? We're gonna focus on x minus 1, right? I said that a while ago. Focus on the one at the bottom or inside the radical. Ignore the radical sign. So what is inside? X minus 1. And then what's next, guys? What's next? Equate that into greater than or equal to 0, right? So greater than or equal to 0. So therefore, what is x? Are we adding both sides by 1? Yes or no?
Yes.
Yes. So x should be greater than or equal to 1. Okay? Here? So this means how we write this in interval notation. Greater than or equal. Greater than or equal, is this a closed interval or an open interval? Once you have greater than or equal, it's going to be closed interval. So therefore, when we write that, it's going to be close at 1. And what is the direction? Greater than. That means to the right. Very good. So the right, infinity, right? So 1 to infinity. Since it is infinity, is it open or closed? Open or closed?
Open.
Open. So what is the symbol for open? Parenthesis. Very good. So this is now the final answer. Okay? The bell rings at 9:20, right? Yeah, 9:20. And I move this up now to do the composition of functions. How functions is being decomposed. A while ago we compose and then we decompose. What do you mean by that? We're gonna chop, right? Okay. So, can I move this up now? So the composition of functions. Functions given analytically can often be decomposed into less complex functions. Okay, this is the h. This h is the result of f and g, right? F and g. Okay, since the first thing is square root, that means what you notice, guys? That means the f of x is square root of x. Square root of x. What happened? Okay. That's how the function is being decomposed. From h of x is equal to square root of x squared, x to the power of 3 plus 1. And then, what you notice right here, a while ago, what did we do for an x? Replace that x into parentheses, and after that, put the inside function. And what do you think is the inside function? It is the g of x, right? So what is g of x right here? The g of x is x cubed plus 1. This is how the function is being decomposed. So decomposition of functions such as this. So I'd like you to look at this one. What do you think is the f of x? This is the h of x is equal to 1 over x squared plus 1. So how we decompose this now? Is this now the imaginary x right here? Yes, no. Yes, it is, right? That's the imaginary x. So therefore, the given function, f function, is 1 over x. Okay? And what is g function? What do you think is the g function? X squared plus 1. Very good. Thank you, Isabella. So x squared plus 1. This is a decomposition of functions. So we do now practice. Now I'll give you time to do practice 2.7a, and at the same time I'm giving you practice 2.7b. Okay? So that ends our lesson, guys.